quadratic functions. Quadratic function is the function, and it takes the format f of x, which is y. So we're looking at quadratic functions. Quadratic functions. All right, it takes the form f of x equals to ax squared plus bx plus c, where a, b, and c are constants. A, b, and c are constants. All right, and it is necessary that a should not be equal to 0, and it is necessary that a should not be equal to 0. So I want to look at this one. This is in the form of f of x is the same as y. Y is equal to ax squared plus bx plus c. This is a quadratic function. This is a quadratic function. All right? But the graph that is formed out of this quadratic function is what is called the parabola curve. So the graph formed by quadratic function is what is called a parabola type. Is a parabola or parabola type. Parabola curve. So examples of quadratic functions as follows. Examples of quadratic functions, i.e. y is equal to 3x plus 4x plus 5. All right. But now look at this parabola, the parabola curve. The parabola curve, all right. Initially, has sometimes it takes this format. Sometimes it takes the format of like x squared plus f of x is equal to x squared plus 1. F of x is equal to 3x plus 4x plus 2, right? F of x is equal to minus x squared subtimes. Now let's look at it takes the format of that. It takes the format, it takes the formats, it takes the format. An example. So how do you construct a quadratic function? What? A example of quadratic function. That is function. Wait, is this one? Four. Yeah, 4. That's 4. So examples of parabola. I think a parabola will take the following format. Let me just give you examples of parabola. Example. Construct a parabola from the function f of x equal x squared plus 1 minus, let's take minus 1. What you have to do, you do like this. First, construct a table of value. Table of value for the function for f of x is equal to x squared minus 1, i.e. f of x, which is y is equal to x squared minus 1 minus x and y minus 2 minus 1 0 1 2. These are independent variables. Then when x is minus 2 squared minus plus 4 minus 1 3. X is minus 1 minus times minus plus 1 minus 1 0. X is 0 1. When x is 1 2. When x is 2 0. When x is 0, negative 1. All right? When x is 2, 3, Note, quadratic functions, a parabola has two values of, can have two values of the values sometimes, I mean, I've got two values correspond of similar values. Sometimes I've got two similar values corresponding to each other. Two similar values correspond to each other. I.e. 3, 3, 0, 0. Now, let's draw the graph. This graph y, x, 0, 1, 2, 3, negative 1, negative 2, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, y, x. When x is negative 2, y is 3. Is here. When x is negative 1, y is 0. This is here. This is negative 1, y is there. When x is when x is 0, y is when x is 0, y is negative what? Here, negative 1. X1. When x is 1, y is 0. Is here. When x is 2, y is 3. So when you look at this one, 3 is corresponding to this one. 0 is corresponding to, I mean 1 is, negative 1 is corresponding to this one. Here. So what it means there is, you do like this, it goes like that. This is what is called parabola, where it is y is equal to x squared minus 1. Why are we saying minus 1? Because it is, you are turning, this is the turning point here. This is called a turning point. Turning point is at negative 1. That's why you have got the number here at the end, where this y is equal to x squared minus 1. This is our turning point at negative 1. Turning point. So in other words, the turning point according to this one, this is called minimum. It's a minimum point. So the minimum point is here. Minimum, or the turning point. Turning point is sometimes known as the minimum point. Minima. So sometimes this is referred to as the minima. Minima or turning point, it is here. That is the parabola. So our parabola is this one. That is our parabola. We have got two sets of values. Two sets of values corresponding to each other. And there'll be one point which is what is called a turning point. That is what is called a parabola. So it takes the form y is equal to x squared plus 2x plus. So that format there. Let's look at another parabola.
So if the graph has turning points, will be parabola as well.
Which one?
Let's assume that the graph has
two turning points. How come will that have two turning point?
Let's assume the figure is continuous and then the graph.
Okay. Let's assume that it has something like this.
Yeah.
No, it's not going to be a parabola. It's not. It's not. That would be now another graph. If it goes like this, it's now another graph. This will be now the turning point. This will be maximum, minimum, maximum, minimum. So that will be another different. But only when we talk about a function, a quadratic function. This is what is called a quadratic function graph. So a quadratic function graph, it takes that. All right. All right. Now, sometimes you can have a graph of this nature, assuming a graph of y is equal to x squared plus 1. Plus 1, this graph, if you plot it very well, you will notice that plus 1 will be up here. Our turning point will be plus what? So it's going to go like this. This is a graph of x squared plus 1 is going to be this. But with the negative, it's going to be something like that. Right? A graph of y is equal to x squared. A graph of y is equal to x squared is another parabola. Turning point is here. A graph of y is equal to negative x squared. Y is equal to negative x squared. It's going to be something like this. Negative. Positive is going to be this. Negative is going to go something like this. This is our turning point. But if it is negative x squared plus 1, it means that it is going there. Plus 1 is the turning point. So our last digit here, the last number here, it is telling you where you are turning. That's the turning point. In other words, the turning point can either be minima or can be maxima. Minimum or maximum. Right. Now, let's look at you can test that, you can look at that. I will not, but let's go to what is called an absolute value function. An absolute value function. Let me define what is an absolute. Something that is an absolute or an absolute value function. That's what we want to look now. And we want to construct an absolute value function. You have to pay attention here. Pay attention here. absolute. And you want to see what is it. Let's go to an absolute value functions. What is an absolute value function? We'll define that. Absolute. This is as dried out. Absolute value functions. I'm defining an absolute value functions. And the way the absolute value function is a function comprises of negative and absolute, negative and positive. I think I will see. All right, an example is this one. Let me define an absolute value functions. I assume that this absolute value functions is defined as f of x the absolute, it is symbolized by two bars. Absolute is symbolized by two bars, like two bars here. That is an absolute. An absolute has two values. It has what is called positive value and negative what? Value. That's why it is called an absolute. It is an absolute because it has two values, positive and negative. Let me give you an example of an absolute value. Assume that this function, this value, an absolute value, is defined by x such that if x greater or equal to 0, negative x, if x is less than 0. If x is less than 0. The first one if x is all right. The question would be construct a parabola, construct a graph representing this. Construct a graph representing this. Actually, if you had to construct that graph working, I'm doing it. In other words, that x has to go to positive and negative, all right? But conditions are these ones. These are the conditions. If x is greater than or equal to what? 0. Something that is greater than or equal to 0, it goes up. X is greater or equal to 0. It means that this x is greater or equal to 0. If it is greater or equal to 0, it goes from this is 0, greater than 0. It goes like this. This is greater than 0. Condition number 1. X has to be greater or equal to 0. This is the graph. And condition number 2. X should be less than what? Less or equal to 0. You are here. Again, you are going this way. This is your y. This is your what? X. That's what is happening here. That x is an absolute. It goes there. It goes there. If x is greater or equal to 1, it means you could have started at 1 here. That and the other one. If x was saying, if they had said this is 4, it means we would have started negative 4 somewhere there, positive 4 somewhere there. But because they're talking about 0, that is, it holds like that. So I've got this graph here. This graph is the word absolute, means that the thing has to go both ends, positive or negative. That's the absolute. An absolute value. Absolute value is a value comprises of 2 elements, and these are positive and negative. Right now, where? Oh, if you had seated this side, are you able to see? Okay. What I'm saying is, see, the word absolute, it means that it takes 2 what? Values. It is positive and now here, condition number 1. Y is equal to x. Y is equal to x, such that x is starting at 0 above. So which means x is greater than 0 and what? It is starting at x. No, y is defined by x such that x is greater than 0. You are here. Greater than something is more than 0, right? Like this. It is going, we don't know where it is going. Condition number 2, such that the same y is minus. Plus is this side. Minus it is this side. But this x has to be greater or equal to 0. That's why you are going this way. This is minus x. This is x. It goes like this. That's why we have got this. X, it means it takes positive and negative values. Have you understood? Huh? Good. Let's look at another element here. Natural domain and range of functions. Natural domain and range of functions. Absolute is that. What you have learned, you have to know that is that an absolute takes 2 values, positive and negative. Then what we are looking at is natural domain and range of functions. Natural domain. Yes. And range of functions. All right. Natural domain and range of functions. All the input values which can be given to a function is called natural domain, and corresponding answers or output values are called range. That one we already looked at that. I think I will not talk much about range and that domain, you know, right? Right? I draw something like this. Domain and range. Is it not this class? And I was saying this. Huh? All right. Now, that was mapping, eh? It was mapping. Here, an example. Let's look at an example here. Function f of x, which is x squared. I think I have already given you that. You can draw that using. Here we can give any input values. So function of f of x equals to x squared. Example, function of f of x equals to x squared, like this one. I actually told you that the parabola will be like this. I actually told you that the parabola will be, it's going to go like this. Right? Is that? But the negative one, this is the f of x is equal to x squared, right? But f of x is equal to minus x squared. It's going to be, it will go like this, right? Parabola of like that nature. That's what you learned at Form 4. So you learned about this. Now, if you look at this function here, if you are to draw table values, what will happen will be like this. For it to show like that, you can x, y is equal to x squared minus 2 minus 1 is 0, 1, 2. When x is negative 2, this is going to be 4. So negative gives you positive, right? When x is negative 1, it's going to be 1. All right? When x is 0, y will be 0. When x is 1, y is going to be what? 1. When x is 2, y is going to be what? 4. See, there are two values. All right? Right. This is where it is turning here. Right? That's why I was telling you that it turns here. It is turning at 0 here. Where at 0 it is 0, 0, right? Right? Because somewhere it's going to be 4. Where there is a negative 2, corresponding will be 2. Where there is a negative 1, corresponding will be 1. Yes. That's what is happening here. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. Clear?
Yes.
That's why I actually thought about that. Now, what is it? This is our domain. And this is our range. In other words, negative 2 is mapping to 4. Negative 1 is mapping to 1. 0 is mapping to 0. 1 is mapping to 1. 2 is mapping to 4. Because in that where you have got the domain and range is where you map. We call mapping. 8. You call mapping. By now you know what is range, domain, and codomain. All right. I cannot talk much about Let's go to even and odd function. Let's go to even and odd function. Let's look at even and odd functions. Let's go to even and odd function. What is an even number? What is the difference between an even number and an odd number? I can start it from there. Even number. What is an even number? A number that is divided by 2. What is an odd number?
Number which is divided by 2 and leaves a remainder of 1.
Leaves a remainder of 1. Is 1 an even number or an odd number? Why 1 is an odd number? Okay. Okay. If in a function which is an f of x, we change x by negative x, and the function does not change, then it is called an even function. If a function f of x, we change x by negative x, right? If a function is f of x, here even and odd numbers, right? If a function f of x, if a function f of x, if a function f of x, we change x by negative x, we are changing this. We change x by negative x, we are replacing this one, i.e. f of negative x. We are changing x to that. And the functions does not change, then it is called an even function. And the function does not change, we call it even function. We are calling it as an even function. For example, f of x squared is equal to x squared minus 4. Then we see that f of minus x gives us f of minus x, we are changing minus x to this one, right? So it's going to be minus x squared minus 4. And which gives you x squared minus 4, which is the original function, which is f of x. Then this function is an even function. All right, what it means there is an even function is a function that even when you replace that value with the very same f of x, we are replacing it by negative. We see that it doesn't change at all. When you work it out, you discover that minus x squared, it is positive x. You change only there. It comes back to the original. You are coming back to the original. We call this as an even function. Very good. I like that is very good. I like that. What it means there is wanted to show that this is an even function. An even function is a function that even if you do whatever, it will go back. The function is this one. Then we are saying, let's replace where there is x with negative. Let us replace x with negative. Like this. Let us replace x with negative here. You will be like, where there is x, you put negative x squared minus 4. See, we have replaced the x with the negative here. Right? So what is negative and negative? Positive. Minus 4. Negative, positive. Positive x squared minus 4. We are going back to this one. Whatever we are doing here, we are going back to the first one. Then that means that is a what? An even function. It's an even. If you replace this with a negative x, negative, positive x squared, we are coming to this. That is what is called an even function. So an even function is a function when you play around substituting, you go back to the original. That's an even function. Let's proceed. An example. Consider a function f of x, which is x squared minus 1. Consider this x squared minus 1 as that function. When you consider, let's consider another example. Consider the function f of x if you know this graph, we have already learned that this graph, it is a graph of this. Negative 1 is where negative 1 is here, all right? Negative 1 is here. It's where we are going to turning. It's the turning point, right? All right? But we don't know where it's going to cut here, where it's going to cut here. That's why if you want to know where it's going to cut there and there, it's where you have to use table of values. So table of values. So you can draw a table of value. In other ways, you can do like this. X, Y. This is the function. X is negative 1, 0, 1. Let's put like this, 2. Negative 1, positive 1 is 0, right? Right? X is 0, negative 1. X is 1, 0. X is 2, 4. 4 minus 3. Right? So there are 2 points here and these points here. All right? All right. Now, what it means is that when X is negative 1, this is X. And this is Y. This is independent variable. Now, you have to, every day I'll be mentioning about independent variable. Independent variable. A variable that does not change, but it affects the other side. What is changing is the other side that is changing. For example, growth. For you to grow, there are a lot of things that you require. Food, water, what. So growth is something which is a standalone. It is causing the other side. So the effect, you are going to see the effect in the other side, whether something is growing or it's not growing. That's why I've got dependent and independent variable. Now, when you look at negative 1 is here, 0, 1, here, Y. So it's going to be something like, if you look at here, let's go here, negative 2, Y, X. Yeah. Okay, I know what you are doing. I know. Is something here. Calculator, what is the calculator is doing? When he does x squared minus 1 and is putting negative 1 squared minus 1, akupeza zola quick. All right? But what you are supposed to do, you are supposed to say x is negative what? Open bracket, negative 1, close the bracket, then you put 1 minus 1. That's what it means there. Not 1. When you put this one to the power what? To the power 2. You find something 2 like this. It goes like this, minus 1. Then you are going to get what you are to find. Yes. It's every number that has a negative here is what you have to do is use brackets. Especially, yeah, here use brackets. That's why at MSc you scored low points because of that. You were thinking when you did that and you went home, you said masamu da konza, but the came results you got 9. That was the reason. So you have to, you can have a gun but failing to shoot. I can give you formulas, but you cannot even know how to use the formulas. That's the issue with the mathematics. So the best thing is you have to be using your. That's why I advise you students to be bringing calculators, so that you have to learn how to play around with your calculators. Otherwise, you can go Facebook. If you do Facebook, all right. Now, Let's go to that now. You saw that's the use of your calculator. Can you be using your calculator very well? Make sure that you put the brackets and then you square that, you put it, and it's going to come up with the right answer. But if you can't put this, you can't waste your quick. All right? Because what you are doing is you have feed it with wrong information. Then that is the wrong information. You know, it's going to put that in memory, so it's going to give you the wrong information. Right now, with this one, what it means there is this is the turning point. You go like this. It goes. This is a parabola, right? And this is what is called the smallest point, right? This is the minimum, right? Minima. You learned you guys minima and maxima, right? At form 4, right? The turning point, right? Yeah, minima. Unless if the teacher was lazy, could not even know how to do this one, but it was a minima and maxima. And again, you have to do this one when you are doing linear programming. You know what linear programming? Yes. Others, they don't know. That's the problem. There were other sums which were the teacher could say this is a feasible region, and he could shade. And those are what are called linear programming. And the aim behind this, they wanted you to find the highest value where. That's why you can maximize, maximize the profit, right? Because others you left the sum at MSCE. You said it is very difficult. But it was a very simple because you had to put somewhere minimum and maximum. So I think that is like that. Let's proceed. And how many minutes to go? I think today I will not leave. I think I will leave you on at least a very good time. Right. From the same graph, draw a graph of. All right. Reflect the graph. Y equals 1. Can you find y, graph of y, f of x is defined by 1 and -1. I want my graph here. These are two graphs. So draw this graph. These are two what? Okay. Now, if I say draw this graph, if I give you draw graph function. This is the function f of x such that x is equal to f of x is y. Yeah? Y is equal to 1 and negative what? 1. If I don't give you the condition, what it means there is when 1 and -1, this means y. Y is 1, right? Huh? Yes. Okay. Y is 1. All right? So if this is a graph y is 1, it means graph of y equals to 1. Well, what is changing is x, right? Graph of y equals 1 is you have to have 1 somewhere. You put it there. -1 here, you put it there. All right? But according to what I want, I let me take this one, a graph of not f of x, because f of x is y, right? But I wanted a graph of where x equals. I wanted this graph where the graph is x is equal to 1 and -1. X is equal to 1 and x is equal to minus what? In other words, it is this graph. I'm not talking about y. Graph of x is equal to 1 minus what? In other words, what I'm trying to mean here is absolute x, such that it takes absolute of x, right? And this absolute of x, where this gives us 1 and -1. So when you look at that one, when x is 1, what is changing is y. When x is 1, you take 1 is here. What is changing is y, right? You put it's a graph of x equals 1. Right? Yeah, y equals 1, when I come by 1, but x of equals 1 is something like this one. And the graph of x equals to -1, -1 is here. What is changing is this is -1. This is a graph of x equals to -1. What is changing are the values of y. But the value of x remains to be the same, 1 and -1. So it is here, it's going to be, so it is passing here. Right? Consider this one. Another example now. Tukuchoka kumeneko, tupita ku Seeko now. Seeko. University in Mene. When you say university, where are you? I'm at university. Which university? University of Freedom. Where? But really, yeah, so this is university. Let's go to another thing, which is how do we construct a graph of a circle? We'll go at 20 minutes to 12, right? But 20 to 12, we'll repeat it. Yeah. So what you can do is we can start signing, The moment you start signing, mangozo akuti kunyumba kukunukira. Bring to design. This is the smarts. Oh, today is what? 25. 10. 10 to 12, 10 to 12. Yeah. But sign up signature. So as you are signing, the moment this paper is there, I will stop teaching you. So if you start signing and it goes to past 12, while it is still there, we should be continuing. But ukuchiambe chizipita. Let me say something about a circle. Consider a circle of radius 2. You know what a circle is? What is a circle? A circle is a circle. All right. Consider a circle with radius 2. Consider a circle with radius 2. What is radius? What is radius? Okay, radius is radius. All right, consider a circle with radius 2 drawn at the original of the XY plane. Drawn at the original of XY plane. You learn about the planes, right? And some of the planes, they're the Cartesian plane. Equation of this circle the equation is equal to xy plus x squared plus y squared is equal to 4. That's it. Let me explain it there.